Okay, in today's video we're taking a look at this aigostar par38 floodlight. Now I got this from the flea market. I have no idea how old it is, but it seemed fairly expensive. I don't know, it's probably not that expensive, but and I changed the light I had in my kitchen with this one. It had a pretty cool vibe. And it did flicker on this side, right? It was noticeable, but it was definitely only one LED. And so it did flicker quite a bit. Let's say, I don't know, a total of 5 on hours or maybe less. And then it crapped out completely. So I turned it on 10 times tops. I'm starting a new Excel, looking at how these LEDs fail. I've been meaning to do this for quite a while. I have a huge bag of lights I mean to analyze and potentially fix. Let me actually show that. So I've been accruing lights from the recycling bags, the recycling bins at the stores. And yeah, I do have quite some. And I just haven't gotten around to actually start to fix them and populate said Excel. But this light is dear to my heart and I do want to keep using it actually and not go back to the one I had before. Some sources estimate this at 30 euros, which I don't know, I think is a bit much, although I don't know. Seems like a pretty serious lamp. And I'm hoping this will simply and very easily pop out, which it seems to do. Damn. All right, this is a serious piece of plastic. And I paid 2 euros for this, so, and I'm not sure we need to go into great depth as to what failed here. But since we're in here, we should, I mean, I don't know. I'm not sure we'll be able to liberate this easily. So in this particular case, I think, well, let's try and open it further. I don't know. Makes for a good video. So maybe we can also decrease its power slightly because as we can see, there's definitely some issues. Are these wires super melted? Because they don't look too good. So let's check if we have any short. No, we don't. That's fine. And between these, yeah, we don't. It's fine. All right, I can see quite a bit of thermal compound there, which is good. Well, not a huge amount, but I mean, they did try, so I'll give them that. And for 33 bucks, you really would expect it. Okay, so using the boost mode on this, which is 380. Usually I run at 280, so this is already too hot to touch. All right. Ow, 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 fuck.
It's easy. Anyone can do it. Millions of people do it.
I do appreciate they did put a lot of, they left a lot of copper on this aluminum PCB so as to spread the heat as best as possible, but this LED just simply could not handle it. And I would expect this can to, okay, so it does lift off quite nicely. All right. And then we have this tiny board here, which I would expect to either come out nicely, just to have some press fit connections, or maybe we'll have to take some wires out and go the hard way. We'll see. I honestly still don't know. Oh no, they have a wire. Damn. How am I gonna get that out? Alright. Yeah, we'll see about that. This is making matters quite worse. We have what seems to be, yeah, it's an inductor, so L2. And we have two current sense resistors, which we'll definitely be working on. This I can actually leave on and just add a tiny bit more. So what do we have? It's definitely these two on the main current path. Bright power chip. We'll put the data sheet on the right side. I'm hoping it's going to say confidential because that's always good fun. Fusible resistor, not much going on. A bit of suppression on the inside, on the input, sorry. Again, so what do we have here? So now they're both this way. No output capacitor. It wasn't flickering, so I'm not sure if I'll add one. Maybe I will. Probably won't. So 5R10. Is that 5.1 ohms and 2.2 ohms? So are these in two parallel arrays? Well, it sure seems like it. You can see up top, they go 2 and then 2. So is this one actually shorting? Because in this case, maybe that's why. Why did it die? Maybe the controller just died. So anyway, let me try some better snips. Fingers on my fingers, which has never ended too well. I would imagine this cooked for an extensive period of time. Yeah, so actually they are in two parallel because I could see the flicker, but that would not affect the light output. So yeah, I'm worried the controller is also dead, but I do have some LED drivers from salvaged LED neon replacements. So I'll most likely be using one of those. I'm also careful not to scratch too deep, as the aluminum backing shouldn't be insanely hard to pierce through, right? And I don't want to short everything to ground, although this is a plastic bulb. Shouldn't be too big a deal. Zoom in ridiculously much. Right now we don't have any quality, but yeah, this should be fine. Right, so let's actually test if this has any output for the explosion, and yeah, it's not super happy. Let's actually measure it when it's in this squealy state. 300 volts, okay. So I'm suspecting now that this LED, let me actually unplug this completely. So I'm suspecting that this LED fried, right? Completely died of exhaustion, and then this one somehow blew open circuit. So my theory now is that we should bridge this gap and just eliminate the one bank, the one 2 LED array out of the mix completely. So I'll be doing this right now. I'm hoping solder will stick on here, which it is. Okay, so we always have these solder spikes when working with large heat planes, heat sinking planes, grounding planes, whatever you want to call them. Yeah. Well, let's see. I mean, this is current controlled, so how badly can it explode? Let's find out. Boom. All right. Let me actually bring my sunglasses. All right, so I think I'm ready now. Let's do this again. That's still pretty bad. Anyway, let's see what voltage this runs at now, and we'll add... Oh my god, there's another one failing. So I don't know if this is visible, but there's another one dying. I'll try and block it. So there's one here. Oh my god, all of them are dying. This light is not looking good. Not in good shape. And it does smell toasty hot. Which it is. I don't know what we can do. I think this is beyond economical repair, unfortunately, so we'll be having however many milliamps this is putting. $190 milliamps. Okay. Always remember to plug out of the amp range. And yeah, I think that's about all. So unfortunately, this has been a case of a widespread LED failure caused by excessive heat, caused by simply overrunning the LEDs, right? Because this is a pretty large surface. I mean, it does have to go through this plastic, which is not great, and it's really thick. Maybe it's a bit thermally conductive, but not a lot. So yeah, let's really quickly go over the XL. All right, so here we are. 18 watts, sudden death. Dying, multiple dying LEDs, excessive heat. All right, age, I don't know what to put this at. Who knows? I mean, it's definitely going to age faster if it's in a closed fitting, right? Weight, let's actually weigh it. Okay, so these are the results. 33 euros estimated. I don't know, they said 50 euros and they've dropped it down to 33. I don't know. 18 watts output, 200 grams. Flicker on one LED, then sudden death. Multiple dying LEDs. It is not repairable. But yeah, anyway, so this has been it for this video. If you have any remarks, let me know down in the comments. Otherwise, have a good day.